Good day, students. So we will discuss Module 5 Volcano Hazards. At the end of our lesson, you should be able to explain various volcano-related hazards, recognize signs of an impending volcanic eruption, and then interpret different volcano hazard maps. There are 53 active volcanoes in the Philippines. The Philippines belongs to the Pacific Ring of Fire, where the oceanic Philippine Plate and several smaller microplates are subducting along the Philippine Trench to the east and the Luzon, Sulu, and several other small trenches to the west. So there are about 300 volcanoes in the Philippines. 53 of these are active, while the larger percentage remains dormant as of the record. The majority of the active volcanoes are located in the island of Luzon. The 6 most active volcanoes are Mayon Volcano, Hibok-Hibok Volcano, Pinatubo Volcano, Taal Volcano, Canlaon, and Bulusan Volcano. In our figure is the representation of Taal Volcano eruption. So Taal Volcano now is at level 4, with hazardous eruptions still possible to happen. Data shows that sulfur emissions, one of the key parameters for monitoring active volcanoes, have been present but low since the initial eruption of Taal Volcano. So volcano may form in subduction. A subduction volcano forms when continental and oceanic crust collide. The oceanic crust melts and migrates upwards until it erupts on the surface, creating a volcano. A volcano may also form in convergent plate boundaries. So if two tectonic plates collide, they form a convergent plate boundary. Usually one of the converging plates will move beneath the other, a process known as subduction. The new magma or molten rock rises and may erupt violently to form volcanoes, often building arcs of islands along the convergent boundary. A volcano may also form through the divergent plate boundaries. So divergent boundary also form volcanic islands, which occur when the plates move apart to produce gaps that molten lava rises to fill. Current research indicates that complex convection within the Earth's mantle allows material to rise to the base of the lithosphere beneath each divergent plate boundary. Tectonic setting of the Philippines. The tectonic setting of the Philippines is a complex. It is characterized by a number of small plates squeezed between two convergent plate margins, separated by small subduction zones and major transform faults. The currently active volcanoes in the Philippines are found on several corresponding volcanic arcs, which can be simplified into two major north-south trending arcs, the Luzon and the Mindanao volcanic arcs. So in our image is the representation of tectonic setting. As you can see, the plate tectonics in the Philippines is complex and includes plate boundaries that are changing rapidly. Several microplates are getting squeezed between two convergent plate margins. So in our legend, the black triangle represents active subduction zones with teeth on the overriding plate, while white triangles represents inactive subduction zones with teeth on the overriding plate arrows, transform or strike slip faults in this kind of area. Last, we have the red triangle represents volcanoes active in the last 10,000 years. So this image shows the tectonic setting of the Philippines in the upper part of our map. In the west, as you can see, is more steeply east-dipping subduction of the Eurasian plate, South China Sea basin, and the transitional oceanic continental crust of the Palawan Block. Along 560 miles or 900 kilometers length of the Manila and Salot trenches produces a discontinuous line of active volcanoes from Taal in the south to Iraya in the north. Volcanism associated with this subduction zone began about 10 million years ago. So in our legend map, as you can see, the red triangle is equivalent to the erupted volcano about 1900 to 1994. So followed by an orange triangle, volcanoes erupted 0 to 1900 after that or AD. We have the pink triangle represent the volcanoes erupted less than 10,000 years ago. So it follows the representation also of tectonic setting in the lower section or in the lower portion of our map. So in the east, a shallow west dipping subduction of the Philippine plate at the Philippine Trench produced a line of volcanoes from Balot in the south to Mayun Volcano in the north. The volcanoes of the Philippines are produced at the junction of the Philippines tectonic plate and the Eurasian plate. The volcanoes of the Philippines rank as most deadly and costly in the world. About 13% of its historic eruptions have caused fatalities, most notably at Taal Volcano and Mayon Volcano, and 22% of its eruption caused significant damage. So for our example, the Taal volcano is the most deadly in the Philippines, killing more than 6,000 in its history. Volcano Island alone has 47 craters and 4 volcanic craters that form when hot magma comes into contact with shallow groundwater, producing a violent steam explosion. Other vents and eruption points are underneath the Lake Taal. The entire volcano island has been marked as a permanent danger zone by PHIVOLCS. Lahar. Lahar are also called mud flows, are very common in the Philippines because archipelago along has often heavy rains. Tsunamis accompany eruption in the Philippines more often than in any other volcanic region. Since establishment of PHIVOLCS, the Philippine Institute of Volcanology and Seismology, the impact and damage of eruption has been significantly reduced. So Lahar is a rampaging slurry of thick debris, pyroclastic material, and ash, and water washed down by the rain from the slopes of, for example, in a Mount Pinatubo eruption. So in the years, the eruption, seasonal monsoon rains eroded Lahar deposits and carried them down to the lowlands. So for example, in Pampanga, we have the evidence of Lahar dried in particular place near the cliff of the volcano. So tsunamis, on the other hand, in the Philippines are rare, but could be devastating. So in the past, 38 people drowned as a result of a tsunami caused by a magnitude 7.1 earthquake happens in Mindoro on November 15, 1994. So the Philippine Institute of Volcanology and Seismology, or the PHIVOLCS, is a service institute of the Department of Science and Technology that is principally mandated to mitigate disasters, that may rise from volcanic eruptions, earthquakes, tsunami, and other related geotectonic phenomena. So we have the maps of the Philippine volcanoes in the Philippines' major tectonic features. Volcanic hazards. So volcanic hazards involves the following: the lava flow, the ash fall, or what we call this, the tephra fall, pyroclastic fall, lahars, volcanic gases, debris avalanche, ballistic projectiles, and tsunami. Those are all belong to volcanic hazards. Volcanoes. Now we will define volcanoes. Volcanoes can be exciting and fascinating, but also very dangerous. Any kind of volcano is capable of creating harmful or deadly phenomena, whether during an eruption or a period of quiescence. Understanding what a volcano can do is the first step in mitigating volcanic hazards. But it is important to remember that even if scientists have studied a volcano for decades, they do not necessarily know everything it is capable of. Volcanoes are natural systems and always have some element of unpredictability. So, as the term says, no, volcanoes are opening in the Earth's surface. So when they are active, they can let the ash or gas and hot magma escape in sometimes violent and spectacular eruption. So the word of volcano originally comes from the name of the Roman god of fire, Vulcan. Volcanoes are usually located where tectonic plates meet. They can also have advantages. For example, volcanic ash contains many minerals which make the soil very fertile or arable. The Earth's crust around a volcano is so thin that it is easy to win energy from the heat of the Earth. And volcanoes attract also the tourists. So as a fact, no, Yellowstone volcano will also destroy the whole world. Will have a possibility of catastrophic eruption will destroy all life on Earth. Volcanologists. Volcanologists are always working to understand how volcanic hazards behave and what can be done to avoid them. So, in fact, most of a volcanologist's work is done studying the remains of either dead or dormant volcanoes, or by monitoring currently present volcanoes that may be active or reawakening. Basically, the goals of volcanology are to understand how and why volcanoes erupt and how to predict the eruptions. They know when a volcano is about to burst, so they can get people out first or send warning signs. So the main purpose is to protect the people in the whole community. Volcanologists also study the past, the old eruptions, and how long they last. Volcanoes leave up lots of deposits behind made up of residue of all shapes and kinds. The warning time preceding volcanic events typically allows sufficient time for affected communities to evacuate and to implement response plans and mitigation measures. So volcanoes plays a very important part in our society. So here are a few of the more common hazards, some of the ways that they are formed and behave. Please note that it is intended as a source of basic information only and should not be treated as a survival guide by those who live near a volcano. Always listen to the warnings and information issued by your local volcanologists and civil authorities. So we have the lava flows. Lava is molten rock that flows out of the volcano or volcanic vent, depending on its composition and temperature. Lava can be very fluid or very sticky or viscous. Fluid flows are hotter and move the fastest. They can form streams or rivers or spread out across the landscape in lobes. Viscous flows are cooler and travel shorter distances and can sometimes build up into lava domes or plugs. Collapses of flow fronts or domes can form pyroclastic density. Density currents discussed later. So, as the statement says about lava, lava is a molten rock, or what we call this the magma, that has been expelled from the interior of some planets, including Earth, and some of their moons. No, in the moon, we have different volcanoes. So a lava flow is a moving outpouring of lava created during a non-explosive eruption, effusive eruption. When has stopped moving, lava solidifies to form different kinds of igneous rocks. The cooler the lava, the higher the viscosity. That is the principles in viscosity. That makes the lava so sticky or very sticky. So pyroclastic flows are so fast, like lava, and so hot that they can knock down, shatter, bury, or burn anything in their path. Even small flows of lava can destroy buildings, flatten the forest, and farmland. When pyroclastic flow mix with water, they create dangerous liquid. So as we have this already in our lecture, the pyroclastic flow mixed with water is called lahar. Most lava flows can be easily avoided by a person on foot since they don't move much faster than walking speed. But a lava flow usually cannot be stopped or diverted because lava flows are extremely hot, between 1000 to 2000 degrees Celsius. 1800 to 3600 degree Fahrenheit in equivalent. They can cause severe burns and often burn down vegetation and structures. Lava flowing from a vent also creates enormous amounts of pressure, which can crush or bury whatever survives being burned. Pyroclastic density currents. Pyroclastic density currents are an explosive eruptive phenomenon. They are a mixture of pulverized rock, ash, and hot gases, and can move at speed of hundreds of miles per hour. These currents can dilute, as in pyroclastic surges, or concentrated, as in pyroclastic flows. They are gravity driven, which means that they are flowed down slopes. So, in addition, a pyroclastic flow, also known as pyroclastic density current or pyroclastic cloud, is a fast moving current of hot gas and volcanic matter, collectively known as tephra, that flows along the ground away from a volcano at velocities of 100 kilometers per hour, averages 62 miles per hour on average, but it is capable of reaching speed up to 700 kilometers per hour. A pyroclastic surge is a dilute turbulent density current that usually forms when magma interacts explosively with water. Surge can travel over obstacles like valley walls and leave thin deposits of ash and rock that drape over topography. So the difference between a pyroclastic flow and a pyroclastic surge is one of a degree. Flows are more dense than surge. Consequently, they tend to follow topography along predictable paths. So they are found flowing everywhere in our geographical surroundings. Surge are less dense, they move more quickly and can surmount topography such as hills and ridges. A pyroclastic flow is concentrated avalanche of material, often from a collapse of lava dome or eruption column, which creates massive deposits that range in size from ash to boulders. Pyroclastic flows are more likely to follow valleys and other depressions, and their deposits infill this topography. Occasionally, however, the top part of pyroclastic flow cloud, which is mostly ash, will detach from the flow and travel on its own as a surge. So this explains that pyroclastic flows form in various ways. A common cause is when the column of lava, ash, and gases expelled from a volcano during an eruption loses its upward momentum and falls back to the ground. Pyroclastic flows can also form when a lava dome or lava flow becomes too steep and collapses. Pyroclastic density of any kinds are deadly. They can travel short distances or hundreds of miles from their source and move at speed of up to 1000 kilometers per hour or 650 miles per hour. They are extremely hot up to 400 degrees Celsius or about 750 degrees Fahrenheit. The speed and force of a pyroclastic density current combined with its heat mean that these volcanic phenomena usually destroy anything in their path, either the warning of crushing or both. Anything caught in a pyroclastic density current would be severely burned and pummeled by debris, including remnants of whatever the flow traveled over. There is no way to escape a pyroclastic density current other than not being there when it happens. So in addition to this, pyroclastic flows are mixtures of hot gas and ash, and they travel very quickly down the slopes of a volcanoes. They are so hot and choking if you are caught in one, it will kill you. On the margins of pyroclastic flows, death and serious injury to people and animals may result from burns and inhalation of hot ash and gases. One unfortunate example of the destruction caused by pyroclastic density currents is the abandoned city of Plymouth on the Caribbean island of Montserrat when the Sulphur Hills volcano began erupting violently in 1996. Pyroclastic density currents from eruption clouds and lava dome collapse travel down valleys in which many people had their homes and inundated the city of Plymouth. So, constructed on historical lava deposits near the long inactive Sulphur Hills volcano, the town was evacuated in 1995 when the volcano resumed erupting. Plymouth was eventually abandoned permanently in 1997 after it was substantially burned and mostly buried by a series of pyroclastic flows and lahars, as you can see in our image. That part of the island has since been declared and no entry zone and evacuated, although it is still possible to see the remains of buildings which have been knocked over and burned, and objects that have been melted by the heat of the pyroclastic density currents. So, what happened to Montserrat after the eruption? So, during this time, Montserrat was devastated by pyroclastic flows. Volcanic eruption and lahars have destroyed large areas of Montserrat. The capital, Plymouth, has been covered in layers of ash and mud. Many homes and buildings have been destroyed, including the only hospital, the airport, and many roads. Pyroclastic falls. Pyroclastic falls, also known as volcanic fallout, or when tephra, fragmented rock ranging in size from millimeter to tens of centimeter, fraction of inches to feet, is ejected from a volcanic vent during an eruption and falls to the ground some distance away from the vent. Falls are usually associated with clean and erupted columns, ash clouds, and or volcanic plumes. So in this image, at the bottom left, explains the different types of pyroclastic flow, or pyroclastic surge. In terms of pyroclastic fall, ash eventually settles after being carried high above the volcano in a vertical plume, as you can see in our figure. On the other hand, pyroclastic flow, uh, fast-moving, concentrated density current of steaming pyroclastic material, travels fastest near the bottom. So they are concentrated at the bottom of the geographical soil. We have also the pyroclastic surge. So they are extremely fast um, compared to a hurricane speed. Density current of steaming pyroclastic material, concentrated density current of volcanic debris, travel fastest at top, very dangerous. So pyroclastic flow is very dangerous compared to the other types of pyroclastic. Tephra. Tephra in pyroclastic fall deposits may have been transported only a short distance from the vent, a few meters to several kilometers, or if it is injected into the upper atmosphere, it may circle the globe. Any kind of pyroclastic fall deposit will mantle or drape itself over the landscape and will decrease in both size and thickness the farther away it is from its source. So tephra, Greek for ash, originate from Greek for ash. It's a generic term for any airborne pyroclastic accumulation. Individual eruptive fragments are called pyroclasts or fire fragments. So, as in addition to this, closer to the surface, as you can see in our image, the bubble increase in number and size so that the gas volume may exceed the melt volume in the magma, creating a magma foam. The rapidly expanding gas bubbles of the foam can lead to explosive eruption in which the melt is fragmented into pieces of volcanic rock known as tephra. Tephra falls are usually not directly dangerous unless a person is close enough to an eruption to be struck by larger fragments. The effect of falls can be, however, ash can smoother vegetation, destroy moving parts in motors and engines, especially in aircraft, and scratch surfaces. Scoria and small bumps can break delicate objects, dent metals, and become embedded in a wood. So tephra is unconsolidated pyroclastic material produced by a volcanic eruption. So how does a tephra deposit form? Explosive eruption produces ash. All explosive eruptions generate tephra. Fragments of rock, just like scoria that are produced when magma or rock is explosively ejected. The largest fragments, blocks, and the bombs sizes about 2.5 inches diameter, can be expelled with great force but are deposited near the eruptive vent. A good example is the eruption of Washington Mount St. Helens. So Mount St. Helens. In this type of eruption of Mount St. Helens, the magma blasts into the air and breaks apart into pieces called tephra. Tephra can range in size from tiny particles of ash to house-sized boulders. Okay, so that is a very dangerous, no, when it comes to sizes, no. So the maximum size would be house-sized boulders. Explosive volcanic eruptions can be dangerous and deadly. They can blast out clouds of hot tephra from the side or top of the volcano. Some pyroclastic flows contain toxic chemicals that can be absorbed into plants and local water supplies, which can be dangerous for both people and livestock. The main danger of pyroclastic falls in their weight. Tephra of any size is made up of pulverized rock. It can be extremely heavy, especially if it gets wet. No? Most of the damage caused by falls occurs when wet ash and scoria on the roof of building causes them to collapse. So a pyroclastic flow is a hot, typically 800, more than 800 degrees Celsius, or about 1,500 degrees Fahrenheit. Chaotic mixture of rock fragments, just like scoria, dust, and ash that travels rapidly per second away from a volcanic vent or collapsing flow front. Pyroclastic flows can be extremely destructive and deadly because of their high temperature and mobility. So moving on to Lahar. On the other hand, Lahar flows like liquids. But because they contain suspended material, they usually have a consistency similar to wet concrete. They flow downhill and will follow depressions and valleys, but they can spread out if they reach a flat area. Lahars can travel at speed of over 80 kilometers or 50 miles per hour and reach distances dozens of miles from their source. If they were generated by a volcanic eruption, they may retain enough heat to still be 60 to 70 degree Celsius or 140 to 160 degree Fahrenheit when they come to rest. So in addition, a lahar is a violent type of mud flow or debris flow composed of a slurry or of pyroclastic material. Lahars have the consistency, the viscosity, and approximate density of wet concrete fluid with when moving solid at rest. Pyroclastic material. The pyroclastic material injected into the atmosphere may have global as well as local consequences. When the volume of an eruption cloud is large enough and the cloud is spread far enough by wind, pyroclastic material may actually block sunlight and cause temporary cooling of the Earth's surface. Following the eruption of Mount Tambora in 1815, so much pyroclastic material reached and remained the Earth's atmospheric that global temperatures dropped on an average about 0.5 degrees Celsius. This caused worldwide incidents of extreme weather and led 1816 to be known as the year without a summer. So when a tambura erupted in April of 1815, the blast was so loud it could be heard 1,200 miles away. The sulfur dioxide released by the explosion was then distributed around the world by high altitude winds, blocking some sunlight and eventually cooling the Earth's atmosphere. Tambora's catastrophic eruption The Tambor's catastrophic eruption began on April 5, 1815, with small tremors or small ground movement and pyroclastic flows. A shattering blast blew the mountain apart on the evening of April 10. The blast, pyroclastic flows, and tsunamis that followed killed at least 10,000 islanders and destroyed the homes of 35,000 more.